With that, we're going to jump right into my talk, turbocharging your development workflow with Roslyn and CodeFix. So as I said a minute ago, my name is Blake Helms. I am a software development manager at EBSCO Industries. However, contrary to the manager part, I know how to write code. So, sorry if there's any other managers here. No, I've been with EBSCO a total of 13 years. I actually left and came back, so I'm what they call a boomerang. And I manage a team that Samir back in the back is on, and I used to have Brandon on my team. Yes, yeah, he left. But I really love working at EBSCO, really doing a lot of cool stuff. And so really this talk tonight is based on a lot of the experiences we've had at EBSCO and some of the things that we wanted to improve about our process. Also, my Twitter handle is @HelmsB. Follow me for what that's worth. And I'm also going to try to post the links to the source code and all the stuff you're going to see tonight. Well, most likely I'll post it there, so check that out if you're interested. First off, what is static code analysis? Anyone want to take a shot? Okay. I'm sorry? So basically what we want to do is look at our source code without actually having to execute it to see, are there problems with our source code? Are there going to be things we could do better? This all kind of came about from the early days of the compiler. So back in the day when you would have a compiler, it would go through and take your code and then convert that into the machine language. And so when computational time was very expensive, this was a very straightforward process. It was just doing a single pass, trying to go through as quickly as it could. That's why we would use, in most cases, assembly code, because you wanted to define, all of your code at the time ahead of time. As we've gotten more computational power, we started to use this to do things like determining whether or not variables are being used and not even predicting them. Doing things like seeing, are we following good coding standards? And so that's really what we're talking about when we talk about static code analysis in this, is we want to create the sets of rules to say, does my code meet the quality gates and quality guidelines that we set forward? So there's a really popular tool called SonarQube, and we're going to take a look at that in a little while. It's great. It has a lot of neat stuff. But what we want to do is we want to take and extend that. We want to go one step further. So that's where the Roslyn compiler platform comes in. So back in 2010, Microsoft showed off the first community technology preview of something that ended up becoming the Roslyn compiler platform. And basically, when Microsoft built the .NET framework, they built a compiler, and it had been running for about 10 years. Okay, but what they were seeing is it was making things a little bit difficult to continue to advance the platform. It was also meaning that companies like ReedSharper were having to build their own pseudo compilers. All these other companies wanted to add static code analysis rules. They were basically bolting on their own stuff. And so Microsoft was in a position and said, why aren't we letting everybody do that? What if we provided a set of APIs that our users could use, and that would allow them to extend our compiler platform? And so with that, we got Roslyn. So Roslyn, and the reason it's called a compiler platform and not just a compiler, not only is it the compiler, which is part of most software development tool chains, but it's also the set of APIs that allows us to interrogate the code and to have a very standardized declarative way for seeing, does the code meet the standards that we want? So tonight, I'm almost out of slides. So tonight we're going to determine what we want to analyze, find the node in the syntax visualizer, register a rule for that node, get the logic for the rule, the CodeFix provider, which we're going to talk about a little bit in a minute, the fix, and my favorite part, write unit tests to verify the code fix. So looking at this as it is, there's going to be a lot of things that are going to look forward to, like what is the syntax visualizer? What are nodes? What is a CodeFix provider? We're going to go through all of that. The other thing that I kind of want to, I want to say warn everybody, we're going to be looking at code that at first glance is going to look kind of complicated because it's going to be dealing in namespaces that you've probably never been in. It's going to be dealing with some concepts that you may not have really ever worked on. But the thing I want you to take away from tonight is even though it might look scary at first glance, it's really not that complicated when we break each part down and look at what each piece does on its own. So we're going to go through this a couple of times, and I'm hoping that this will kind of whet your appetite, that you'll think of, here's a bunch of rules I want to go create to help my development process and to catch the types of mistakes that I'm making that are potentially costing you or your company money. And with that, let's jump into the demo. So first off, because static code analysis and building Roslyn Analyzer is a little bit more esoteric than building websites, it does not come straight out of the box. But there are two really easy ways to add it, depending on which version of Visual Studio you're on. So if you're on Visual Studio 2015, you're going to want to search for the .NET Compiler Platform SDK, download this plugin, and it will automatically install itself into Visual Studio 2015. If you're on Visual Studio 2017, it's a little bit easier. So you'll open up the Visual Studio installer, which you would find through the Start menu. And if we go to Modify, we can change what components are built into our copy of Visual Studio. So one of the big changes in Visual Studio 2017 is you have workloads, which will install a whole set of components. What we care about in this case is individual components. So if we look here, we can scroll down. Brandon, would you mind getting me something to drink real quick? So in this case, the .NET Compiler Platform SDK, check that box and then hit Modify. It'll automatically install all the necessary tools into Visual Studio. So let me close that. And we're going to open up. So Brandon may be able to answer this question for me. What is my biggest pet peeve when it comes to code?
Squirrely braces.
Or lack thereof. So one of the things that I just cannot stand are tests without curly braces. There's just few things that set me off more than that. So when I started looking at the Roslyn compiler platform, my first thought was, I am going to push my will onto everyone that ever has to touch code that I'm involved with. And so I'm going to write a Roslyn Analyzer for this. So how do we get started? Let's open up a new copy of Visual Studio. Oh, and I got my little cheat sheet just in case. So when we open this, we're going to have a couple of new project types that we didn't have previously. So let's go File, New Project. So you can see if we go under Extensibility, there is this Analyzer with CodeFix. So that's the one we want. So I'm just going to call this If Test Analyzer. You can type. That all looks good to me. One of the nice things with this template is it's actually going to have a working example right off the bat. Now, it's a pretty useless example in that you would probably never have this rule, but it's something that we can at least look at to see how it actually works. So first off, once this loads, we're just going to go ahead and run the project it created and then see how it works. So, trying to be a little slow today. So we have two main classes that we really care about. The If Test Analyzer from our Department of Redundancy department, and the If Test Analyzer CodeFix provider. So in this case, we're going to look at the Analyzer class. So first thing we'll see is it's filled a couple things in for us. So we have this diagnostic ID, and what that is the unique ID that you would, like if you were a Microsoft code rule, is what you would hopefully search Google for if you wanted help with it. So like Microsoft IDs will be like CA39247. In our case, we're much less creative, and so ours is if test analyzer. And then we have a title, a message format, a description, and a category. So as you can see, these are by default created as resources. If you intend this to be used in multiple languages, then you can keep it as a resource. Mine, I'm not, so I'm just going to go ahead and fill these in. But title, exactly what it says. Message format is basically your description, except you can interpolate a string into it. So you can say this variable does not meet this standard. So you can give a little bit better information to the user. The description, like it says on the 10, it's the description for it. And category is a fairly important one. This is a set of standard categories that are shown in Visual Studio. So in this case, this particular rule that came out of the box has to do with naming. We'll see why in just a minute. The one that we're going to be doing here shortly is going to be under syntax. So the next line is where we are creating the rule. So we're basically taking all these values that we set up here, and we're creating a new rule of these of type diagnostic descriptor. So again, basically right out of the box, we can use everything they've given us. We just got to go fill in the blanks. Now, a couple of things you'll notice is we have this diagnostic severity. Right now it's set to warning, so you'll get just little squigglies. If we set this to error, it actually could stop the compiler from running. So it's a good way if you've got something that's particularly egregious, like not having curly braces with if tests, then you can break the build and not allow them to check in. And then this is enabled by default is true. That will allow you to determine whether or not it's enabled by default. Now, both of these can be overridden once the user has installed this. And one thing I should say is once we have this built, it can either be compiled as a NuGet package, and you can include it in your project. It can be sent out as a Vizix file, so a Visual Studio extension, or we can create a SonarQube rule. And so we're going to look at those here in a minute. So we created a rule, and next it's going to pass it to this array called supported diagnostics. So we're basically saying we've created a new diagnostic rule. Whenever you run this, we want you to have this as one of your list of acceptable ones. When that happens, first thing that's going to happen is this override is going to be called initialize. And in this, we're going to tell it what we want to do. So in this case, we're saying anytime you come across a symbol that is of any type, so a class name, things like that, we want you to run this method to see if we violated any of our rules. So the nice thing with this is Microsoft's doing the hard job of going through and determining whether or not it should even be running on this line of code, because we're telling it we only care about particular symbols. So we could add multiple here. If we had several different conditions, we could add more registrations, or if it applied to multiple, we could do that. If we look at our analyze symbol method, we can see it's pretty simple. So basically it's saying I need to find the symbol that we're referring to. Now the nice thing is you notice we're testing it as name type symbol. We don't really have to do any checking because we know the only way you could have gotten here is if it's a name type symbol. That makes it nice and easy. The next thing, in this case, you're saying if your name type symbol is not uppercase, then throw an error. Don't know why we'd ever want to do that, but they're checking to see if there are any lowercase characters, and if so, they're creating the rule and throwing the alert, so reporting a diagnostic. If we run this, we'll actually get to see it in action. So when I start it, what this is actually going to do is going to build, and it's going to spin up a brand new instance of Visual Studio. This instance of Visual Studio is clean. It doesn't have any of the other plugins turned on, so it makes it a nice sandbox environment for you to try things. Well, one of the benefits is when it opens this new Visual Studio, we can actually run our code. Let me close this other one. We can run any solution we want. So in this case, I have my my F-Brace Analyzer test project. I think I may have messed it up. Let me start that over. So if you had a particular project, nope, actually just came up. Let's see, did I mess it up? Nope, I think it's good. So I can see I have my solution. So I'm just going to open up my little sample project. So if you were building a a rule for something that you're working with in an actual project, you could test it out this way. So this is not like you have to go create just a fake sample project. You can actually use it on your real code to see, does this actually solve the problem that I want to solve? So I have 3 instances of Visual Studio, which is not taxing this machine. Let's see. So once this comes up, we'll see that it will run the code analysis and that we should get our rule in place. While this is coming up, are there any questions on what we've gone over so far? Just FYI, we're going to be looking at all of these things again as we build our custom rule. So, well, actually, because you can distribute it as a NuGet package, it can work with other platforms as well, like VS Code. Fortunately, this is for .NET now, but there are some rumors that other languages that end up being pulled into Roslyn could gain support for it as well. So anything that Roslyn can analyze, it can work against. So right now, it's finishing loading. In a second, we should see here. And we do. So if we click on that, we see we get our little light bulb of enlightenment, and there is a make uppercase rule. And again, I have no idea why we ever want to do this. So now we know that out of the box this is working. So let's write our own custom rule, because the days of no curly braces are over. And actually, I should not have closed that. Let me reopen it. I'm just going to open this in another. So when we look at this code, there's several things that you may not be immediately familiar with. So we have things like registering symbol action, analyzing symbols. What are symbols? How do I know which one I'm going to use? This is where a really powerful tool that comes with the .NET Compiler SDK comes into play. What we're going to look at is the syntax visualizer. So it's going to allow us to look at what the compiler is seeing so that we can figure out what we need to plug into these different places. So as you get to using this more, you'll kind of know, but this is going to be a good way for us to figure out how we're going to build this rule. So we've already established what we want to write. So we know that this is bad and this is good. So let's open up our visualizer. So it's under the View menu, and if you go to Other Windows, and then Syntax Visualizer, this is going to show us exactly what the compiler sees. If I click this, I can actually see how all the tokens are being represented behind the scenes in the compiler. Let's take a look at our if test. So if I look here, you can see we have an if statement. We have our if keyword, and we have leading white space and trailing white space. They're marked as trivial because we don't care about them. And then we can see we have our open paren, our equals expression. And just FYI, if some of my stuff looks a little bit different, I have a font called FireCode, which automatically, like if you do equal, it makes it look like one equal. And if you do exclamation equal, it makes it look like a not. So just in case you're wondering where those came from. We can see our expression. We can see the numeric. So as you can see, as we're clicking through here, or I can click on one individually, it tells us our type and our kind. So one of the ways we know that we're going to be working on the if conditions, so we can see we're going to be using an if statement. So if we click on that, we can say the type is if statement syntax and the kind is if statement. That's going to come in handy because in a minute we're going to have to tell it what we want it to only register. So we're going to do a register syntax action, and we're going to tell it we only care about if statements. So now we know that. But how are we going to determine whether or not this has curly braces? So one thing I found is very helpful is create a version that is not the way you want it and to create a version that is the way you want it. And you can compare those two to try to get an idea of how we would do it. Let's go back and look at our first one again. So we can see that we have our if keyword, our open paren, our equals, our close paren, and then our expression. So our if condition, open paren, expression, what was that? Equals expression, close paren, and then our expression. Well, if we take a look at this other if test, let's see if there's anything different. So let me expand this one as well. So, other than the white space, which we really don't care about, we have our open paren, we have our equals expression, we have our close paren, and then note that it says block. Let's expand that guy. Well, if we look, that block contains our braces and our expression. So what we can surmise from this is when we have it right, we would have a block coming after this closed paren, and in the way that we don't like, we don't. So we know we're going to be looking for a type of if statement, and we're going to be checking to see is the statement that is covered by that if a block statement or not. If it's not a block statement, then we know something's not right. So let's take what we've learned from there and let's see if we can put it into practice. So let me close this. So first off, let's go ahead and make this a little bit cleaner. So we're going to get rid of all this title stuff. So we're just going to call this brace tester. And message format. In this case, we don't really care because we're not going to be doing, there's no message to give back to the user other than the, hey, you need curly brace to run your if test. So we'll just say that. And because we're not actually doing any type of string interpolation, we're not doing anything there, we're just going to make our description the same. No real reason not to. Okay, so we have our title, our message format, and our description. Now the category. So in the other one, we had naming because we were talking about whether or not your variable was named what we wanted. In this case, this is a syntactic issue. We're saying that your naming is all fine, but you're not using curly braces. So we're going to change this category to syntax. And this will control where it shows in the error list in Visual Studio, as well as if you're using a code analysis tool like SonarQube. And then our rule should be basically wired up. The only thing is we're going to change this from a warning. Let's see, error. There's nothing stronger, so I guess that's what we'll use. It will be enabled by default. And we're going to point it to our supported diagnostics. So you can see, in this case, we've changed very little code from what was there by default. So we haven't gotten anything really complex. The next part is on initialize. So in this case, previously we had a symbol. In this case, we're doing syntax. And does anybody remember what the syntax kind was? The one we were looking at? A statement. So we're going to change this from symbol kind to syntax kind, which is just another enum. And then we'll change it to statement. And since we changed it to syntax, we're not going to use register symbol action anymore. Can anybody take a guess what it's going to be? There you go. It's going to be a syntax node action. There's a syntax tree action, but we're saying we only want this to apply to a node, not the entire tree. And so you'll see it's still giving us squigglies, and the reason is because right now we're passing it into a method that takes in a symbol analysis context. So we're going to change this to a syntax analysis context. Syntax node analysis context, rather. You can see our error went away. Just because I'm a stickler for consistency, we're going to change this to syntax. As you can see, I mean, we've made a couple of changes, and they've been fairly logical. While they may seem a little daunting at first, they're not too bad. We can infer, once we know what the kind and type is from the if statement in the syntax visualizer, it's starting to make sense. Now let's go through and let's look at what else we're going to change. So our named type symbol. Well, in this case, we're going to be looking for an if test. So or an if statement. So let's change that. And we remember from our syntax visualizer, which I closed again, dang it, it said that the type was if statement syntax. So from the syntax visualizer, we found our kind, which we plugged in here. We found our type, which we plugged in here. Now, instead of saying a symbol, because we are dealing with syntax nodes, we're going to change this to node. So we're saying find this node in the tree, just like we saw in the visualizer, and cast it to type if statement syntax. And again, we're safe being able to do a cast without any checking, because we know the only way we could have gotten here is if syntax kind was an if statement. So now we don't really care about this. We're going to, I'll erase that in a second. First of all, what if the statement has curly braces? What would we want to do? Nothing. We want to return. The very first thing we're going to do is see, is it already what we want it to do? If so, we don't want to spend any more time computing it. So we're going to look at our, ironically, we're going to use an if test, and we're going to look at our if statement. And so off of that, we are going to look at statement. So if we remember from the visualizer, we had our if statement, then nested under that was the actual statement. So what this is going to do is say, essentially, what is the code that comes right after the if statement? So with this, there is a isKind method. And we're going to say the syntax kind is block. Let's see. Then we know that it has curly braces, and therefore we don't need to do anything. So looking at our if statement, looking to see what the next line is, seeing if it's a block, which in case it has curly braces, then we go on. We put our curly braces, like the good Lord intended, and then we return. So now we've handled the happy path. So this was a good programmer. He's already gone through. He's done everything right. So now we need to figure out what we want to do if you didn't do that. So we're going to do a new variable, and we're going to call it non-block statement. So this is what we are going to find if we did not find curly braces. Now, this is going to be of type expression statement syntax. And we know that because when we looked at the visualizer, we saw that you're either going to have a expression statement, meaning something under the if test, or you're going to have a block. Since we already handled the block case, we're safe to assume that it's going to be an expression. If the code is not compiling at a higher level, so if you've written an invalid if test, you're never even going to make it to our code. So we don't have to worry about those edge cases. It's one of the beauties of using the Roslyn compiler platform is Microsoft handles that for you. So we're going to cast our if statement dot statement. Then we're going to do one last check, and this is really just, I tested this and you really didn't need it, but it makes me feel better and sleep better at night. So we're just going to make sure that it's not null, because if it is, for example, they're in the middle of typing, it would not blow up. When I tried it last night, I could not make it blow up, but at least now we're handling the null condition. Now we've handled happy path, we've handled the null path, so now let's go and actually create our rule. But we know that if you've made it here, then you have violated our rule. So this is where we can steal some code from down here that was already written. So I'm just going to move that and then delete this. So again, we're reusing what already came, except we're going to make a couple changes. So in this case, we see our name type symbol dot location. We're going to do our if statement dot statement. Actually, no, we want to do our non-block statement. What this is going to do, and location. What this is going to do is it's saying we found the code that's not contained in curly braces. Find what line number and column position you're on, and pass that. This is how we tell Visual Studio where to put the green squigglies. I could actually have these squigglies like anywhere on the screen if I pass the wrong numbers to it. This is how we would do that. Then our context.report diagnostic, that is the default how we bubble it up to the UI. So let's try it out. So we're going to hit start. And then once our other instance of Visual Studio, oh, where did I miss a curly? Yeah, I have a box full of them. Do I need to take out a curly brace? Making sure y'all are paying attention. I don't like curly braces. I just like curly braces after an if test. I have a very specific desire for curly braces. So while this is coming up, let's see. Open up our. I'll give you a little backstory around that. Who here has heard of the go-to-fail bug? So go-to-fail was a bug on the in iOS where if your SSL was invalid, it would say, "Great, let me let you right on through." And part of the reason was, let's see, there it is. So you can see here, a merge error, this would not have caused a problem that millions of devices at risk. So there are practical reasons to my madness. So let's open up our if test curly brace tester. That also came from our Department of Redundancy department. And when that loads, we should see our green squigglies. Here we go. If we actually try and run this, it should throw an error. And that didn't happen. Okay, I'll figure that out. We can see that we at least got the red squigglies. And if we hover over our light bulb, we'll see that I haven't created I'm surprised to see that one. Oh, I bet you it's still left over from the last time I ran it. So it's great that we identified it, but let's help the developer out. Let's go fix it for them. So this is where CodeFix comes into play. The CodeFix is a way of taking the code and fixing it in a way that the developer can just click the light bulb and have it automatically correct. So when you're writing an analyzer, please create a CodeFix. It's no good just telling people there's a problem. Let's go fix it for them. So if we look at our CodeFix provider, we can see we still have all the old stuff. So in this case, make uppercase. It's going to be very similar. So we're taking our diagnostic ID from our analyzer. We're adding it to our array. And then we are, I love the name of this, well-known solve providers. I don't know who came up with that. This is going to basically be the same. We're going to have this asynchronous task for actually doing our code fix. Anybody want to take a guess on why it's very important we make this async? We didn't make it async, and every time you typed a letter or anything, Visual Studio had to stop and see, can I recompute how to fix your code lock up the UI a lot. So the last thing we want to do is give the developer a bad user experience and constantly lock up their UI. Because the first thing they're going to do is pull out our plugin. Now they're going to be writing if tests without curly braces all over the place. So we don't want them to do that. So we are going to go through a couple of steps. And actually, we're going to go ahead and just start fixing this. So we want to make this not make uppercase, but did I? I'm going to have to look at my other one. I think I took a screenshot of the wrong one. Nope, I just never changed it. That must be why it is showing me too. So we're going to make this add braces. And we don't have to change anything here, nor do we have to change anything on the get fix all provider, but we are going to start changing things on our register CodeFix async. So in this case, the way this works is it deals with the context of the document. So the document, think of it as everything within a window. When we were looking at our source code, the document is that source code. The first thing we want to do is we want to get the syntax root. So we're saying, take that like we had the syntax visualizer, find the root node and give it to me. Async, so we have to pass it the cancellation token. I'm going to get into the async and all that. Just know you need to pass on the cancellation token that we have in our context. And then this can pretty much stay the same. This again has to do with our async, but really what we want is at the end of this, we want to have the root syntax tree because we're going to go manipulate it. So next, we have our diagnostic and diagnostic span. So the diagnostic is we added a diagnostic to the set when we threw the alert. So now we said, okay, we have it in the diagnostic list. We need to go pull it back so that we can use the information from it. So in this case, the source span, when we set the non-block statement dot get location, that's going to give us this here. So what we need to do is find the diagnostic that we're working on, and we need to find where in the code it's located. And once we do that, then we can actually go through and find it in our root. So in this case, we're going to do root, find token. So we're going to take our root syntax tree. We're going to walk it, find the one that we need. So we know we can do this diagnostic span.start. So if we have a root tree that's 1,000 nodes long, but our first error isn't until 997, there's no sense in looping through all 1,000. Let's start at 997. We're saying, in this case, give it our parent and any ancestors. The difference is rather than the type declaration syntax, we're going to change it to if statement syntax because we're dealing with if statements. So other than that, everything else we can pretty much keep just like we got it. And then we need to register our CodeFix. So we're going to pass along our title. We're going to call a method where we actually do the work. So this is kind of like the initialize method earlier. We're just setting up to say when you have this type of issue, here's how you fix it. Now we're going to make a couple changes here. So we're going to change the name of this because we're not doing make uppercase. So we're going to do add braces async, and we'll change this to add braces async. We are still going to pass in the document. The declaration is going to be fixed in just a minute because right now it's waiting for a type declaration syntax. So we're going to change that to an if statement syntax. So again, the things that we looked in the visualizer earlier and we found, we're still using those. And then the cancellation token, we're just passing that on along. You know, nothing fancy there. So let's go down here. And I'm just going to start some new. So the first thing we need to do is we want to go and find our non-block statement. So we want to look at that code that wasn't set up correctly earlier. So var non-block statement. And we can do, say, expression statement syntax. So we know that it's expression statement because it wasn't a block statement. So again, we can be safe in our cast because the only way you could have gotten here was to have made it through all the other checks. So if statement, oops, was it? I know what it is. And I like my variable names to make sense. So if statement, statement. So this is basically the line of code under the if statement. We need to get that, and I can do that. Now that we have that, we want to make a copy of it, but do it within the context of a expression block. So we're going to do var new block statement. And this is where Microsoft gives us some pretty cool tools. So we have the syntax factory. And I don't know if we've used, I don't think they use that anywhere. So what this is going to do is allow us, rather than having to like take strings and copy and paste them around and do all kinds of crazy things, we're going to tell the compiler, go do this thing and let it do it. So in this case, we're going to take the syntax factory. We're going to create a new block statement, and we're going to pass in our non-block statement. What this is going to do is create a new block statement using the non-block statement. So rather than us having to go and say add curly braces at the front, add curly braces at the end, if Microsoft ever went in, changed, and made euro symbols the new curly brace, we would have it because they would already taken care of it for us. And then this next part is ancestors and self. So basically, what if you had more than one line of code? We don't want it to wrap the first line of code in a curly brace. We want it to do anything that falls below this, so all of its ancestors. So we're going to type if statement syntax. So again, we want to make sure that we're only getting to the if test. So if you had a for each statement below that, we wouldn't want to start mangling things. So this is a way of us doing that. So, actually, that is the next line. Sorry. Hold on. Confusing myself. It's not hard. There we go. No, I see. I was reading up here still. So annotations. I have that namespace loaded. I'll be honest, this line here, I am not 100% sure if it's needed. But the example that I originally pulled from had it. And just add it. Okay, so now we're going to take, so we have our original incorrect statement. We've corrected it. So what do we need to do with it now that we've actually, we've gotten it corrected? Replace it. So we're going to get our root. So again, we're going to await pulling the document, because what if you found like some really terribly built class and it was like 30,000 lines long? You would not want this thing sitting there while it's trying to ingest all that. So we're going to do that as a precaution. Now we're going to do get syntax. Get syntax root async. So again, we want to get the top element and work our way down. So we will do that, and then we're going to pass in our cancellation token. Because it's async, we're just passing it down from where we got it at the beginning of the method. So now we're going to create a new root. And that is going to be root dot replace node. So in this case, it's the base type is syntax node. So it's the type that we're gonna replace, and we can pass in. So we'll do non-block statement and new block statement. So we're telling it, make a copy of the root, replace this old statement with our new one. Now we have our new root node. Then we just need to do our new document because the root node exists as part of a document. So we're going to document dot, what is it, with syntax root. So we're basically saying, take that the document, throw out the old root, get our new root, and then we're going to pass back the document. So new document. And then we can get rid of all of this mess. Yes, so it is actually overriding the entire yes. But it is smart enough within .NET to only replace the parts that actually changed. So we're giving it, and then it does an in-memory comparison, and then only replaces what needs to be replaced. The other thing, and I'm going to show this because that's actually a really good point. So it's throwing red squigglies because I didn't change this from solution to document. So let me change that. Now let's run. Oop, add braces async. What does it not like? Yeah, that probably should not be there. Let's see. What did I have for? Oh, I made it really easy when I did it my last time. So title. You know what would be a lot faster? Take this, and I'm just going to copy the one that I know works. This is why we do this ahead of time. Oh, that looks worse. Maybe that was a bad idea. I work on a Mac all day, so all the shortcuts are different. Okay, that's all showing good. So let's run it. So now this is going to open up Visual Studio. We'll open up our project again, and we should get a little bit more help. Let's run our if test. This was in VS Code, it would have been open already. I haven't used VS Code, by the way. Y'all should use it. Awesome. Yeah. Yeah, I think I've got three instances plus PowerPoint and several other things. I'm on. So, come on, give me my squigglies. Okay, so now if we click our light bulb, come on, add braces. And this kind of goes back to your question earlier, is you can see it's got the whole document in this when it gives us a preview. One of the cool things that I found is that code analysis is even being run on this preview. So if we had other things without other rules, you can see squiggly even in here. So unlike a lot of tools which just go and try to replace one little thing, this is actually a live view of your code. So we said we want to go ahead and apply the code fix. And I feel better already. Everything is good. But there's still one thing that we got left to do. I'm not going to sleep tonight until we do it. We need some unit tests. Because code is not code until it's testable. Now this, I'm going to show you the completed one because it was kind of a pain to get working for one very specific reason, and you'll understand why when I show it to you. So let's go open up my ready-made one. So one thing you'll notice, these green check marks. So I'm using Visual Studio Live Unit Test. So this is a new feature in VS 2017. So I can see that my unit tests are still correct. I could actually, let's go and comment this out. I think it's Enterprise. Which I happen to have here. So let me see. That one may. Hold on. I can come up with a better one. Let's change it. This one shouldn't keep it from compiling. So I'm going to just pass the wrong route in without actually fixing anything. And then in just a second, it should tell me I failed the test if I did this right. Show me if it's running. I'm going to let that keep running. Hopefully it'll show up in just a second. Let's take a look at our unit test. So when you create a new project, you're going to get all of the unit test stuff out of the box. It's just a matter of making the changes for our stuff. The other thing is you're going to get a bunch of helper methods. So you can see this verify C# diagnostic. It's a helper method that you get out of the box. So this first method is making sure that if we don't give it any code, we should not get any warning. And so that's really all that one's doing. Now, if we scroll down a little bit, you can see we are creating, we've created a block of code that we're going to pass to our analysis engine. So I'm giving it a if statement without a curly brace. And if we look at our diagnostic result, it's saying, did I come back with a diagnostic result called if brace analyzer? Did the message say if statement should be enclosed in braces? Is the severity a warning? And in this case, on this earlier version of the project, it is still a warning. And then this was the part that took a while to get you up and working, is you tell it, make sure that the squigglies are in the right place. So I ended up basically running the test, letting it fail, so it could say, expected them here, but I actually found them here, so I could grab those values and stick them in, because trying to like, you know, when I was here and I was like 1, 2, 3, 4, 5, you know, that was just preposterous. And then I have one more test. That test was, let me see, diagnostic and CodeFix should both be triggered. And then my last test is, sorry, that was all in one test. So basically it's saying, look at this. I should get back a diagnostic result saying that I triggered it. Then it should apply the CodeFix. It should look like this. So in this case, I said the curly braces. White spacing matters, which threw me off for about 30 minutes while I was like, this code looks identical. Why is this not working? It's because I had a tab instead of a space in one, and it was throwing it all off. So that's where it can be kind of a pain. But now, let me just go ahead and run these. But now I know that going forward, if I want to make additional changes, I'll know whether or not I broke it. Because like I said, unit testing is very, very important. So now the tests are running, and let's hope one fails. Come on. So our test 2 failed. Let's see if it gives us a reason. It was expecting our if test to be corrected, but it wasn't corrected because I went in and made the change to say, rather than passing the new route back, pass the old route. So basically the CodeFix didn't do anything. I change it back and rerun my tests. It should pass this time. Come on. It all passed. So we know we're all good. So we can check this into source control, knowing that we have good test coverage. So now we've just written a Roslyn Analyzer plugin. We've written a CodeFix provider, and we've written unit tests. So we've done everything we need to start making use of this. So how do we distribute this? One case, and we can see it in our Solution Explorer, we can distribute it as a VSIX file. So this would be like if you wanted to say, everybody on my team or everybody in my company, I want to make sure that they're doing this. They can install this as an extension, and they would get these rules. Now, you may say, I only want to run these rules on all of my new code, but not on my legacy code, or vice versa. So you can, for this project, you can pack it as a NuGet package. You add it to your project, you get these red squigglies only on that project. And then last but not least, is we can make a SonarQube rule. So who here has heard of SonarQube? Okay. So SonarQube is one of my favorite things in the world. So what it is it is a tool that runs static code analysis for your projects. So what it'll do is, let me go back to the dashboard, is we can feed it our project, and it will tell us all of the ways that we have done things wrong so we can correct them. Luckily, my little 5-line test project has nothing wrong with it. But if we created a rule and loaded it into SonarQube, which unfortunately I was having a problem with earlier, so I'm not going to be able to show that tonight, and we're also running low on time. But we would be able to take these rules we've written and write them as custom rules for SonarQube. But if we look at the rules, I mean, there are literally hundreds of rules. So, you know, whether or not you should be using equals, or, you know, whether you have the deprecated tag, all these different things you can have. So right now there are 935 rules loaded, and there will be 936 once I load my rule. So the way you do that is there is a project called the SonarQube Roslyn SDK that you can download from GitHub. And when you run that, you pass in your NuGet package of your rule, and it will create a jar file that you can then upload to SonarQube. So pretty straightforward process. What SonarQube is using for all of their C# rules under the covers. So really good support. This is a way, if you said, like with EBSCO, you know, we have, you know, literally thousands of developers worldwide. We don't want to have to try and load a NuGet package on every single project, or try to make sure everybody's using this Visual Studio installer, or they may not be using Visual Studio. Like Brandon might decide, you know what, I'm going to use Notepad for all my development. And as taxing as that, now I do have one developer on my team that uses Vim for all their development. Stephen Williams, you may know him. This would be a way of, you know, utilizing SonarQube. We could make sure that that is covered as well. Yeah, so this version of SonarQube I just have running on my machine, but what you would want to do is have it as part of your build or continuous delivery pipeline. So we have our build server that actually builds, and then you can say, okay, take the results of this build, pass it to SonarQube, and then get results back. So we have it set to where if you pass it to SonarQube and then SonarQube says, no, you have violated one of our rules, then we can fail the build, make the developer go back to the drawing board and fix it. So it's a way of making sure of, rather than having technical debt just accrue over years, and then like 5 years later, all start pointing fingers at whose fault it was, we get to point the fingers early and do it when you do the check-in. It makes it a whole lot easier. So that's Nope, that's the beauty of it, is it's not even connected. So yeah, this will work with a whole multitude of languages. It was originally written for Java, but we have C#, JavaScript, even does COBOL for all of that. But yeah, so this is essentially like a server platform that you just pass anything to. So this is a kind of an alternative having to do it through Visual Studio. But one of the nice things is they also have a tool called Sonar Lint, where it will download the rules from here and then give you those as warnings in Visual Studio. So before you even get here, you'll know whether or not your code would pass. But this also checks things like code coverage. So if you drop code coverage, this is going to flag you. If you had a security vulnerability, this is going to flag you. And it even has like, what we call the blame bar, where you can go and figure out who put in the code that broke the build. So it's a really powerful tool. And as a manager, I'm looking at this all day long. I'm going through and I'm like, hey, are we dropping code coverage numbers? Are we adding new, they call them code smells. So let me go back. Unfortunately, I can't show you the ones we have at EBSCO. Those would be a little bit more colorful and easier to see. So in this case, because I zero technical debt, I get an A. But if you exceeded a certain amount of technical debt, it can drop you below that. And so what it does is it actually has a little bit of a formula behind the scenes where it tries to measure that in hours. So it'll say, like, you have 23 hours of technical debt. And so it basically is looking at the number of changes, the average cost to change a line of code. The thing that will get real is when you look at this project and you plug in the hourly rate for your developers, it's like, we just created $250,000 worth of technical debt. And it's like, suddenly that becomes real. You can also see that 0.0 like SQL injection. 300 rules are in a SQL injection. You add one of those, that's a flag. We're not going to let that build go out to production. We're not going to let that build hit down, much less production. And then you have the concept of a leak period. And so we can say we work on 1 or 2 week iterations or sprints. We can say we're okay with letting stuff in over the course of a week or two. But in that 2 weeks, it's got to be cleaned up. That way, it's not just constantly, causing you problems. You can give it a little bit of flexibility. And really, Sonar Cube could be an entire talk on itself. There's so much stuff here. It's really powerful. It's free. They do have higher versions that give you a little bit of extra functionality, but right now, like EBSCO, we're using the free one, and we have 200 something projects in it, close to 1 million lines of code, so a lot of stuff. Most of the rules all the rules we're currently using are pre-written. We started seeing these and kind of started piquing my interest. It's like, hey, I wonder, could we write our own rules? And like honestly, we joked a lot about the if test program. That is a rule that will be in our Sonar Cube instance very soon. Another rule that I've seen people write, and that I have one created, is looking for profanity in comments. It's one of those things, like, it seems like a small thing, but it keeps it out of your stuff. Good question. So there's a couple of analyzers aren't available. The biggest one is the analyzer. Although I've not seen very good progress from it. Like, I've seen a demo, and you can get a lot of stuff through. But for what we use it for C#, Java, and JavaScript, it's actually really good. They're pushing out updates like every few days. Well, we'll get new rule sets. It's like 20 new rules that we didn't have before. And so the cool thing is you can set, so we have this quality profile and quality gate. And so right now, this one is just using Sonar Cube way. In EBSCO, we have one called EBSCO way. And it's basically where we can say, you have to meet these certain standards. And then as a team gains operational experience, we'll say, okay, this was good 6 months ago. We're going to crank up the notch a little bit. So it's like, before we required 75% coverage. Now we're going to require 80 or 90. That's something actually in the morning I'm cranking up the one for my team to require a little bit more code coverage and fewer code smells. Yep. So what you would actually do in this case is you would use your quality profiles and your quality gates. So a quality profile is what rules are turned on. So in this case, there's like 122 rules. If I look at my quality gate, I look at SonarQube Way, you can see you would violate the gate if your coverage on new code is less than 80%. If your new bugs is greater than, well, in this case, 0, but I would probably have it, whatever you want to set it to, your technical debt ratio. So you would say, if it meets all these conditions, return a failure of the quality gate, and Jenkins is just looking, did the quality gate pass or fail? Jenkins doesn't need to know about any of this. It's just looking for pass or fail. And honestly, I can actually show you the handful of commands for executing this. This is like right now I have this running as a Vagrant image. Like I just went and downloaded it and about 20 minutes to spin up. But let me look at this. So users. I think it was this one. Yeah, so I just created, because I needed to get this in there, I just created a quick little batch script. So run it through the analyzer. So, this is like if you wanted to run, you could go download this and run it on your local machine and start figuring that out right now. In fact, that's what we were doing until we got our corporate instance up and running, was just running it locally. But it's real straightforward. But yeah, SonarQube, that was something when we implemented it, we first did it, we paid off like 400 or 500 tech debt items in about a week. Because like once we knew about them, like most of them we didn't even know about, like, oh, I can go knock this out. It'll just take me 2 minutes. I'm going to go fix this. We increased our code coverage numbers by 25%. It was just, once all that data was available to us and visible, it gives you a goal. Like, hey, next week I want to make this a little bit better than I had this week. So it's a really good tool. And the thing that I really want to, get across tonight is this is an awesome tool, but with the Roslyn Analyzer stuff, we can make it even better because we can take things that are company specific. So you may say, like for EBSCO, we might say, anytime you show EBSCO on a screen, we want to make sure it's capitalized. So we can actually write a SonarQube rule that says, anytime you use the term EBSCO in the as a string literal, make sure it's capitalized. So, you can do things that are very specific to your company. Looking for credit card information if somebody's doing that. Hard coding passwords. Passwords I know are already in here, but if you do something that's very specific to your industry or things like that, or you constantly do something that you just keep stubbing your toe on. A good example, I think Brandon's got some experience with this, is who here uses Entity Framework. Okay, so one of the things that you have to be really cognizant on of Entity Framework is not to do things like trim and do lower before you've actually executed your query, because what it'll do is it will pull everything and then trim it and then do your query. So you'll find a query that should be running in like 200 milliseconds, but it's taking like 200 seconds. That was something, how many times have we fixed that, Brandon? Honestly, like a half dozen times in a half dozen different projects. Well, now that we know that, we can go create a SonarQube rule and stop it from ever entering the system again. So we can see what struggles does my team or my organization have. Let's go fix that, create a SonarQube rule, and we can start helping to make that better. So it's really all about, we joked a lot tonight, but this is not about getting on to anybody or like, oh, you got to do it this way. It's about how can I help give myself some guardrails, or the bumpers at the bowling alley, make sure that I'm going in the right direction. So it's been a really, really great tool. Other questions? So the first time we did it, we ran into like getting a version of Java. Honestly, was probably the hardest thing. This time I used Vagrant. Who here is Vagrant, by the way? So Vagrant is a tool where you can take like a pre-built container and then run it on your local machine. So if you go to Vagrant, let me just search for Vagrant boxes. They're called boxes. So if I just wanted a Linux server, but in my case, like I wanted a Sonar server, so I used this one from Ungoliath. He seemed reputable. So you can see, like I had initialized earlier, but I ran this command vagrant up. It provisioned a brand new VM with SonarQube up and running, included the database, included everything, so I didn't actually have to do any configuration. I use this a lot when I'm just wanting to test something out, like, hey, I want to try out Mongo. Well, it's like, well, I don't want to have to go spin up Mongo on my machine. I'll go download a Vagrant box, and in 2 minutes I can have it up and running. And we actually, at EBSCO in our Java stuff, we're actually using Vagrant for our development environment. So at the end of a sprint, we wipe everything out, we re-provision it, everything goes back the way we have it. It's all automated, so it puts in all the right paths, and we don't deal with all these issues like, oh, it worked on my box. Every week, everybody's boxes are back to the way they were in this like self-contained environment. I would really suggest, like, if you want to just try it out, Vagrant is really the way to go. What? Docker, let's look. Oh, so it's not really. So Vagrant is really about your local machine. We're doing local development. Docker is more about provisioning and doing things for like deployments. They do something very similar, but Vagrant is a lot lighter weight for what I want to do, because it's like I have an idea where I want to use Mongo or I want to use MySQL. It's like I want to go from idea to being able to like start writing code as quickly as possible. I don't want to have to set up a Mongo instance. I don't want to have to deal with any of that. So like if I want to use Mongo, I can go and I can do a quick search. This guy, he looks good. So literally we can run these two commands in a command prompt once you have Vagrant installed, and in 5 minutes you've got the image up and running. So it just makes it, and you run Vagrant destroy, and every bit of that image is gone. You never have to worry about it again. And you can create your own, like we've created several, but you can search. I mean, there are literally thousands of different boxes here, of all different types. Well, I hope this was helpful. I hope we learned something tonight. So this has been a fun little project for me. It's something I want to be doing a lot more of. So if nothing else, I hope it shows like this is not as hard as it might seem. Like if you just go and pulled up a tutorial, it looks daunting. It's not. And really, I titled this "Turbocharging your development workflow." That was really intentional, because you could go your entire career and never build a static code analyzer. In fact, most people will go their entire career and never build a static code analyzer. But you can really turbocharge your career by taking it to the next step. If you go to your employer or your next job or wherever, hopefully you might come to EBSCO one day, and you say, not only can I write code, but I can write code to help others make better code decisions. It's a win-win. So I'm hoping this will be something you can put in your tool bag and really makes you even more marketable as a developer. So, that's all I got.